On September 25, 1986, a fighter named Engineer Ghaffar raised a 15-kilogram tube onto his shoulder near Jalalabad and pulled the trigger. 3 of the first 4 missiles fired that day hit Mi-24 Hind gunships, the most heavily armored attack helicopters ever deployed in combat, built to absorb machine gun rounds, shrug off RPGs, and dominate any airspace they entered. The Soviet air campaign in Afghanistan never fully recovered from that afternoon. The Hind was not beaten by a superior machine. It was beaten by a design decision its own engineers made 15 years earlier. If you want to understand why the Hind was considered unkillable and then wasn't, subscribe. You're going to want to stay around for this one. Afghanistan in the early 1980s was an air war problem dressed as a ground war problem. The Mujahideen knew the terrain, moved at night, and vanished into ridgelines that Soviet armor could not follow. Convoys were ambushed on mountain roads. Garrisons in the eastern provinces were under near constant siege. The ground war was unwinnable by conventional means because the geography made conventional means irrelevant. The only effective response was rotary wing, helicopters that could loiter, respond in minutes, and engage targets in terrain where jets couldn't operate with enough accuracy to matter. The Mi-24 was the answer, a titanium armored fuselage resistant to 12.7 millimeter rounds from every angle, a 4-barrel Yakushev-Borzov machine gun cycling at 4,500 rounds per minute, 6 weapon hardpoints loaded with 57 millimeter rocket pods, AT-6 spiral anti-tank guided missiles and bombs. It could insert Spetsnaz troops behind enemy positions and strafe the valley floor on the extraction run. Both roles in the same airframe simultaneously. Nothing in NATO inventory could do that. The Mujahideen called it Satan's Chariot. Hunter-killer Hinds operated in groups of 4 or 8, providing mutual fire support. 6 would fly in a figure-8 formation ahead of road convoys, coordinated by a forward air controller in a dedicated aircraft. When rebel forces opened up on a column, the Hinds were already there. The response time was measured in seconds, not minutes. Marat Tishenko, head of the Mill Design Bureau, visited Afghanistan early in the war to see how the crews were using his helicopter. What he saw surprised him. Pilots were performing barrel rolls and maneuvers his own engineering team had considered structurally impossible. He reportedly said, "I thought I knew what my helicopters could do, now I'm not so sure." From 1980 to 1985, there was no effective counter. Soviet commanders used the Hind without serious restriction. The problem it was designed to solve, it solved completely. That changed when a weapon it had never been stress-tested against arrived in the hands of men hauling it over mountain passes on mules. Killing the Hind required 3 things simultaneously: range enough to engage before the pilot could react, guidance that couldn't be spoofed by Soviet countermeasures, and portability light enough for infantry moving through the Hindu Kush without vehicles. That last constraint mattered more than it sounds. The Swiss-made Oerlikon 20mm cannon was considered as a Mujahideen air defense option and supplied in small numbers. Against the Hind, it was technically effective, but the Oerlikon weighed over 200 kilograms. In terrain where fighters were moving on foot through mountain passes at altitude, it was operationally useless. You cannot carry a 200-kilogram cannon to an ambush position and expect to be there before the Hinds arrive. The RPG-7 had range but no guidance. Heavy machine guns had occasional effect on rotors, but none on the armored fuselage at combat altitude. Previous MANPADS gave you 2 of the 3. The missing variable was a guidance system the Mi-24's designers had never modeled, partly because it didn't exist yet, and partly because of a choice they had made in the engine bay. The first weapon Mujahideen fighters used against the Hind was the RPG-7. Cheap, portable, one man to operate. but firing an RPG upward at a moving helicopter requires an angle that sends the backblast into the shooter's own position, and the smoke column marks the firing point for the gunship's next pass. The Mi-24's armor was rated to absorb the warhead unless it struck something critical. Over 4 years of sustained combat, RPG fire brought down Hinds occasionally, not consistently, and not at a rate that changed Soviet tactics. Soviet pilots learned to watch for the smoke. They learned to operate in pairs so that while one aircraft was engaging, the other was scanning for the RPG position. The Mujahideen learned this too and began dispersing faster after firing. It became a tactical adaptation contest, and the Hind was winning it. The closer call was the SA-7 Grail, a Soviet-made heat-seeking MANPADS already in Mujahideen hands through intermediary suppliers. Fire and forget, one man, locked onto infrared exhaust emissions. It scored early kills. The Soviets initially underestimated it and flew without countermeasures. Then Soviet pilots adapted. The SA-7 had a hard physical constraint. It could only achieve lock from the tail aspect, tracking exhaust heat from behind. Experienced crews stopped offering a tail shot. They approached targets from angles that denied the missile a clean acquisition geometry, and they returned to base the same way. Combined with infrared decoy flares, the Soviets began fitting after early losses. The SA-7's effective kill rate dropped close to zero. The Mujahideen reportedly began using the SA-7 primarily as a psychological weapon, firing to force the Hinds to altitude, reducing their accuracy rather than expecting to hit them. Every weapon in the Mujahideen inventory was defeated by altitude, speed, or armor. Every anti-aircraft system the Mujahideen had was constrained to a single engagement geometry. The Hinds pilots simply flew out of it. What the problem required was a missile that had no safe geometry to offer. In September 1986, the CIA delivered the first batch of 300 FIM-92 Stinger MANPADS to Mujahideen fighters trained in Pakistan. The Hind's safe corridor closed. The Stinger did something no previous MANPADS had done in this conflict. It locked onto both infrared and ultraviolet emissions simultaneously. Earlier missiles tracked only exhaust heat from behind. The Stinger's dual-spectrum seeker acquired from any direction, head-on, crossing angle, side aspect. The pilot could no longer maneuver into a safe aspect. There was no longer a safe angle to fly to. It also had meaningful flare resistance built into the seeker. The Stinger was designed to discriminate between the target's heat signature and a decoy flare, meaning the countermeasures that had neutralized the SA-7 provided significantly reduced protection against the new missile. Soviet pilots who had learned to defeat one type of seeker were now carrying countermeasures calibrated for a threat that no longer matched what was in the field. But the Stinger did not succeed on guidance technology alone. It succeeded because the Mi-24's designers had inadvertently solved the targeting problem for it. The Hinds 2 Isotov TV3117 turboshaft engines were mounted inline, a deliberate choice to streamline the fuselage and minimize frontal profile against head-on fire. The logic was sound. A narrower frontal cross-section means fewer rounds connecting in a head-on pass. What that configuration actually did was vent both exhaust streams laterally, away from the main rotor wash that would otherwise disperse the heat signature. Two concentrated, laterally exposed heat columns, one on each side of the fuselage, radiating outward with nothing between them and the seeker head of an incoming missile. Clean acquisition from almost any angle. The crews knew they were exposed. Mi-24 pilots began carrying AK-74 assault rifles in the cockpit, not for air-to-air combat, but for the moment they were shot down and had to survive on the ground. The flaw in the exhaust configuration was serious enough that when Mill built the Mi-24's intended successor, the Mi-28 Havoc, they abandoned the inline configuration entirely, rooting exhaust into the rotor wash as Western attack helicopters had always done. The lesson was incorporated into the next aircraft's fundamental geometry. The FIM-92 Stinger cost approximately $85,000 per round at 1986 U.S. Army procurement pricing. The Mi-24 represented well over $10 million per airframe in comparable dollar terms, plus crew training, maintenance, avionics, and the support infrastructure required to keep it operational at altitude in a desert environment. Dusty conditions alone were hard enough on the engines that the Soviets had to develop specialized twin air intake filters just to keep the fleet serviceable. The life cycle cost of a single operational Hind in the Afghan theater was substantially above the airframe price. One Stinger, one Hind. The cost exchange favored the man with the tube on his shoulder by more than 100 to 1. The CIA supplied approximately 2,300 Stingers through Operation Cyclone, a program that started with $695,000 in 1979 and peaked at $630 million per year by 1987. Saudi Arabia matched U.S. funding dollar for dollar. The total capital flowing into the Mujahideen weapons pipeline at peak was over $1 billion annually. That bought Stingers, yes, but also the Chinese-supplied heavy machine guns, the logistics network through Pakistan's ISI, and the training infrastructure that made the Stinger effective rather than just present. The weapon was one component of a system specifically engineered to raise the cost of the Soviet air campaign beyond what the occupation could absorb. By 1987, Soviet pilots had changed their entire operational doctrine in response. They flew at night when possible, using parachute flares to illuminate targets rather than flying low in daylight. They used terrain masking, popping up to engage from 200 feet and descending immediately. Hinds were assigned to escort jet transports flying in and out of Kabul because even fixed-wing aircraft needed close air protection from the Stinger threat. The operational tempo of the Mi-24 force dropped sharply. The Stinger didn't have to kill every Hind to win. It only had to make the Hind stop doing its job effectively. The Stinger was not cheap. The exchange rate was. The first confirmed Stinger kill of a Hind was September 25, 1986, near Jalalabad, eastern Afghanistan. The shooter was engineer Ghaffar of Gulbuddin Hekmatyar's Hezb-i Islami faction, trained at a Pakistani ISI facility under the CIA program. 3 of the first 4 missiles fired that day hit their targets. The psychological effect inside the Soviet military was immediate. Pilots who had flown without serious concern about MANPADS threats for 6 years were now facing a weapon they had no reliable defense against. The crew's informal nickname for themselves, Mandatory Matrosovs, after a Second World War Soviet hero who threw himself across a German machine gun to shield his comrades, took on a different weight. The last Soviet Mi-24 was shot down on the night of February 2, 1989. Both crewmen were killed. It was the last Soviet helicopter lost in nearly 10 years of warfare. Congressman Charlie Wilson, the primary political architect of the supply program, was given the first spent launch tube. He described those engagements as one of the 3 defining moments of the entire war. We never really won a set-piece battle before September 26th, and then we never lost one afterwards. The tube is now on permanent display at the U.S. Army Air Defense Artillery Museum, Fort Sill, Oklahoma. Honest caveat: this video does not claim the Stinger won the war. Historian Alan Cooperman, writing in Foreign Affairs in 2002, found that within months of its introduction, Soviet countermeasures had significantly reduced its kill rate. Better flares, exhaust bafflers, night operations, and terrain-hugging flight profiles all degraded the Stinger's effectiveness faster than the popular narrative acknowledges. By 1988, the Mujahideen had largely stopped firing them, partly because stocks were being diverted and sold, and partly because the Soviets had adapted well enough to make clean shots rare. The Soviet withdrawal was driven by political and economic pressures that had been building for years before the first Stinger was fired. The Stinger accelerated a conclusion that was already forming. What it changed, definitively, was the operational freedom of the Mi-24. Soviet designers built the Mi-24 to survive the threat environment they could model: air defense artillery, infantry small arms, and first-generation heat-seekers with fixed engagement geometries. That model was accurate against every theater the Hind had entered before Afghanistan, Ethiopia, Angola, the first 5 years of the Soviet deployment itself. The Stinger broke the model at the physics layer, not the tactics layer. No amount of pilot experience defeats a seeker that has no blind spot. The countermeasures already fitted to the aircraft were calibrated for a missile that no longer matched the one in the field, and the exhaust configuration that had been an aerodynamic asset became a targeting aid for the weapon it was never designed to face. The Mi-24 is operating in Ukraine today on both sides of the front line. The engagement math it faces there is familiar: cheap one-way attack drones with infrared or optical seekers, launched from positions that ground forces cannot rapidly locate or suppress. The Hind was designed for a threat environment where the air belonged to the bigger, faster, better-armed platform. That assumption no longer holds when the incoming threat costs $500 and the aircraft costs millions. The problem the Stinger solved in 1986, high-value rotary wing platform against low-cost guided munition, is the defining cost equation of the current war. Ukraine operates Stingers. Russia still operates Hinds. The physics hasn't changed. The Mi-24 was never replaced by a direct equivalent. Russia's Mi-28 Havoc and Ka-52 Alligator are more capable in dedicated attack roles and significantly more expensive per airframe. Neither carries troops. Neither combines fire support and assault transport in the same aircraft. The dual-role capability the Hind proved in Afghanistan, insert troops, provide covering fire, loiter over the objective, does not exist in any current Russian platform in that combined form. As Mi-24 attrition in Ukraine continues, the gap is not filled by a more capable successor. It is left open. The question of what replaces that specific capability is one the Russian military has not answered in 50 years of trying. The Mi-24 was not beaten because it was an inferior machine. It was beaten because its engineers built it to survive a threat envelope that the Stinger dissolved, and an exhaust configuration optimized for speed handed the new seeker exactly what it needed to lock on. The most survivable attack helicopter in Soviet inventory was partly undone by its own design. The successor it produced, the Mi-28, fixed the exhaust problem and removed the troop transport role. In solving one flaw, the next aircraft became something different entirely. That gap between what a weapon system was built to face and what it actually encounters is still the question the Hind is flying into today. Subscribe if you want to understand how that gap keeps appearing 40 years on.